Namaskar. Welcome to this channel Chemistry Made Easy by Dr.ARM. Today we are beginning with the new topic, that is molecular orbital theory, that is shortly called MOT. So this topic is one of the most developed theory to explain the nature of bonding, and also it will help to find out the structure and stability of the molecules resulting from the combination of various atomic orbitals of participating atoms of different elements. Under this title of molecular orbital theory, we are going to discuss, in total theory we are going to discuss, that is the points of study. First is formation of molecular orbitals from atomic orbitals. Under this title, under this point, we will discuss the concept of molecular orbitals. How are they constructed from available atomic orbitals, and what are their stabilities, what are their method, or what are the basis on which the theory is based, and that theory explains how are the molecules stable. Second is homonuclear diatomic molecules. These are the molecules containing atoms of the same elements. So this will explain how are the homonuclear diatomic molecules formed from the participating atomic orbitals of the same element. Third point is heteronuclear diatomic molecules. So in these molecules we have to discuss the molecules containing atoms of different elements such as NH3, H2O, or we are considering here the diatomic molecules such as carbon monoxide we can consider, or any molecules of this type, where one atom is of one element, another atom is of another element. Fourth point is molecular orbitals for larger molecules. So we have to consider molecules containing atoms more than 2, that is 3, 4, etc. Then we have to explain next point, that is expanded shells and molecular orbitals. So there are such type of concepts or points to be studied under this head of the topic, that is molecular orbital theory. So first of all, we will begin here our study. We will begin our study here with introduction. So this theory is using the method of group theory. This theory uses the method of group theory in order to describe the bonding in molecules and the complements and extends the simple picture of bonding. So the picture of bonding means how the bonding is developed in the different atoms of different or same elements. So this is overall considered under this title of molecular orbital theory. For this purpose, it is necessary to consider the concept of symmetry of the atomic orbitals available or provided by the participating atomic orbitals for the purpose of bond formation. If the symmetry of the participating atomic orbitals is matching more or less or exactly, similarly other conditions such as energies of the participating atomic orbitals is also matching, there is no much large difference, then there is possibility of formation of atomic or molecular orbitals from the participating atomic orbitals, and this will produce the considered or expected molecule. So the interaction between the participating atomic orbitals is interesting, and it will determine whether the possibility of molecule formation of the molecule is or not. Similarly, the molecular orbitals are filled with the electrons in the same way as those are filled in atomic orbitals. That is according to the above principle, Pauli's exclusion principle, Ohm's rule of maximum multiplicity, etc. Means all these rules which are expected in atomic orbitals are also expected and considered in case of molecular orbitals. The total energy of electrons in the molecule is compared with the energy of participating atomic orbitals, and if there is much difference in these energies of participating atomic orbitals of one atom and participating atomic orbitals of another atom, then such type of overlap or formation of a bond is not possible. If the difference in the energies of participating atomic orbitals and symmetry is matching, then only the formation of molecular orbital takes place from the atomic orbitals, and this will result in the formation of a molecule. If we say that the energy difference between the atomic orbitals of participating atoms is much larger, then there is no possibility of formation of such a molecule, and in short we say that such molecule does not exist. Further, we will explain the bonding or lack of bonding. We will explain the bonding or lack of bonding in first 10 molecules, that is homonuclear diatomic molecules. We will consider 10 examples of homonuclear diatomic molecules which are starting from hydrogen to neon, and then the expanded then we will consider the expansion of the treatment to heteronuclear diatomic molecules, and also further to multi-atomic systems or molecules containing more than 2 atoms. We will describe both approaches, such as simple pictorial approach and the developing the symmetry arguments required for some of the more complex cases. So these things will be discussed here one by one. Now the first point of this today's interest point of today's interest is formation of molecular orbitals. Formation of molecular orbitals from atomic orbitals. So these molecular orbitals are shortly represented as MOs. And these atomic orbitals are shortly represented as AOs. Atomic orbitals. It is AOs. So instead of writing the full form of the atomic orbitals, we can shortly represent as atomic orbitals as AOs and MOs. So in this point we will discuss how are the atomic orbitals converted into corresponding molecular orbitals. As in the case of atomic orbitals, we have seen that Schrodinger's wave equation is important. So the solution to the Schrodinger's wave equation is different for different electrons which are present in the atoms. So the solution can be written for electrons in the molecules of the resulting molecule, and the approximate solution to these molecular Schrodinger's equation can be constructed from linear combination LCAO, linear combination of atomic orbitals. So this will help us to construct the required Schrodinger's wave equation. This wave equation for linear combination of atomic orbitals is considered for the smallest atoms such as hydrogen. We can consider the example of hydrogen. So here we will consider this example as, so if we see the wave function for this hydrogen is psi. If we use psi as the wave function for hydrogen, so this psi is given as psi A given as Ca into psi A plus Cb into psi B. Ca into psi A plus Cb into psi B. Here we know that psi is the wave function for hydrogen molecule. Then this psi A, this psi A is the atomic wave function, for atom A. Say atom A. Then psi B is the atomic wave function for atom B. Then these Ca and Cb are adjustable constants. Ca and Cb are adjustable constants, and these are positive or negative. These are positive or negative. So these values are found to be in this way, that is, they are either positive or negative, and depending upon the individual orbitals, their energies. So these depends upon their individual orbitals and their energies. Now, after the formation of a molecule, say for example we have two such atoms. The atom is A and B. When the two atoms are there, the atom is A and atom is B. Then the nucleus of A and B should be at such a distance so that the repulsive forces are minimum and attractive forces are maximum. So if we try to bring these two atoms much closer, what will happen? The two nuclei will repel each other. Similarly, the two electron clouds, the electron cloud of A and electron cloud of B, will also repel each other. So the repulsive forces will be more experienced, as a result of which the energy of the molecule will be increased, and that will cause the instability. The molecule will be unstable, and if the distance between the two atoms is much larger, then the attractive forces are weaker and repulsive forces are also much weaker. But because of this, the two atoms could not come together. Electrons in bonding molecular orbitals, if we see, then the two atoms are, say here we will see, these are the two atoms A and B. Then the electron cloud of these two atoms, means say these are the two electrons. So they will occupy the space between the two nuclei. So depending upon other conditions such as electropositive nature of this and this, or electronegative nature, etc., the delocalization of electrons will be different. So that is another thing. But the electrons are occupying the space between the two nuclei, so that the two atoms or nuclei are strongly held at the position by the two nuclei. So this gives the stability to the molecule. Here you will find that the electrostatic force of attraction exists between this nucleus and electrons or electron cloud of this atom. Similarly, this nucleus and electron cloud of this atom are attracting towards each other, and it creates the strong bonding, and this will cause reduction in energy of the system. Further, the bonding requires, what is the requirement of bonding? Bonding requires, so the requirement of bonding is that first condition is the symmetry. First is symmetry. The atomic orbitals of A and atomic orbitals B, if there is possibility or if there is chance to form the molecule, then what is the requirement? The two atomic orbitals participating in this bond formation should have appropriate symmetry. The symmetries should be like, so that the overlap between the atomic orbitals will be maximum. So this condition is explained using the signs of wave functions. So for this purpose, signs of wave functions are shown like that. The sign of wave function is either plus plus or minus minus. Means this atomic orbital, or we can say this atomic orbital here as it is shown. Say A has, for example, positive sign of wave function, and this has also positive sign of wave function. Then the formation will result in the strong bonding, and there is possibility of bond formation. Alternatively, if the two atomic wave functions have negative signs of wave functions, then also the overlapping is strong between the two atomic orbitals, and this will result in the formation of a stronger bond. But if this or this, any of these, or has other sign, means different, if say this is positive sign, then this atom A has positive sign of wave function and this has negative sign of wave function, or alternatively we can say this has negative sign and this has positive sign of wave function, then such atomic orbitals will not show the maximum overlap, as a result of which such type of overlap will not result in the bond formation. Further, the second condition is the energy. Second condition is energy. The energy of participating atomic orbitals should be matching. There should be no much large difference in their energies. If this is not the case, means if we consider them in the energy axis, say the atom A and say this is the atom B, they are lying at nearly the same energy. then only they will undergo overlap, positive overlap we will see. Means they will overlap strongly with each other. In case if any of these two has the difference in energy like this, say this atomic orbital of A is lower energy, this atomic orbital of B is higher energy, then there is no appreciable overlap, or there is no possibility of any kind of overlap. Then such type of overlap will not result in any bonding effect. So that will cause anti-bonding effect. Then third is the distance between the two atomic orbitals or two nuclei. Distance between two nuclei. So as we have seen here, the distance between the two nuclei should be acceptable or appreciable, so that the overlap between the atomic orbitals is considerable. Otherwise, what will happen if the two nuclei are at much larger distance? There will be no appreciable overlap, as a result of which the electron density will not be lying between the two nuclei, and the two nuclei cannot be held strongly with each other. As a result of this, we can say that such bond will not exist, such molecule will not exist. But if the two nuclei are lying at appropriate distance, which we say that internuclear distance, then the nuclear force of attraction between the nucleus and electrons of this atom, or nucleus of this and electrons of these atoms are interacting with each other, and therefore the two nuclei are held strongly with each other. So in this way we can show that the atomic orbitals should fulfill, we can say, these three important conditions, so that the molecule will come into existence. Means by the formation of a bond, the molecule will come into existence. So we will stop our discussion here today, and we will go to the next point, means to the same point, but in order to study the examples in detail. Various examples will be discussed in the next lecture in detail, so that we will understand what is this approach of molecular orbital theory and how it explains the nature of bonding and explains the pictorial nature of these molecules. So thank you very much. Keep watching this video channel. Subscribe to this channel. Please press bell icon and like button. So thank you very much.